Good morning, ladies and gentlemen. Today we're looking at composite functions. Now on the screen in front of you I have the textbook, definition of composite functions is where there are basically two functions with one nestled inside another. And the textbook uses annoyingly different notation. This notation here I'm highlighting I think makes the most sense. That means the function g is inside the function of f. And I'll go through that in more detail later. However, what I've highlighted is exactly the same as this, which is the same as this. So you can expect to see all three. Essentially, just remember the one that comes second is inside. If G is second, it's inside, and F is the outer side. Alright, so let's look at this. F in this case being outside and inside. What this means is that we take the value of x and we throw it into the g function. So into the g function here, we mean that we've taken x, we've multiplied it by 2 and added 3. So double and then add 3, and what we're left with is this. Then that, in turn, gets thrown into the f function. So you see here how instead of, we would expect to see f of x, but instead of that we're seeing f of g of x, which means g of x is being thrown into where we would normally just put an ordinary x or a number in the previous topic. So here, this 2x plus 3 is being thrown into the f function. And all the f function does is raise something to the power of 4. So it's saying x to the power of 4, except if you're not putting in x, instead we're putting in 2x plus 3, what we get out is 2x plus 3 to the power of 4. So if we have f of x is x to the 4, and g of x is 2x plus 3, then f of g of x, apologies, that's an x in there, looks like 2x plus 3 to the power of 4. And particularly when we start calculus, and especially in year 12, it becomes very important to be able to recognize what an outer and inner function is here. So, to give you an examples, note here g of f, which means f is going to occur first on the inside and then it's going into g. So f is 2x takes 7, and then that's going into g, which is x to the power of 4. So our result is 2x takes 7 to the power of 4. Here, f is second, so it's on the inside. G is first, so it's on the outside. So it means we take this function here and put it inside there. So the result is sine, and yes, this works with trig and basically everything. There. So it's saying, alright, we'll take the f first, and then instead of g of x, where that x is, we've now got f of x, so we're going to put f of x in there. Hope that makes some sense. I have another. Here, g of x is first, so we're going to put g of x inside f of x. Alright. Let's look at this example, but look at it two different ways around. Here, we have f going inside g. So if f goes inside g, with these two here, we have 2x plus 4 all squared, which comes out as 4x squared plus, what's that, 16x plus 16. Seems good. What about this way around? Well, this way around, g is going into f. So g going into f looks like 2x squared plus 4, which just equals 2x squared plus 4. So it's important to note that in general, as the textbook definition, f of g of x is not equal to g of f of x. There are particular examples that appear that happens, but in general, we wouldn't expect them to be the same. And that is the end of the video. Nice short one, but as long as you understand that, this here, and I think it's worth remembering that can also be written as f of g of x, And I like that way of seeing it more, but the textbook doesn't often do it that way. And what that's saying is that where you would normally put x into f of x, here you're putting g of x into f of x. Alright, hope that makes sense. I'll see you in class tomorrow. Thank you.